Hello students, in this video we'll see how to find the least squares estimates for the slope and intercept parameters for a linear regression. We have a population when we're doing regression problems. Our population model, or our actual model, is a random variable y is equal to beta 0 plus beta 1 x plus an irreducible error epsilon, where these are the true population. These are the true values of what we know from the sample and the population. And this estimate is, this error is normal 0 sigma squared. It's a random variable, so our population is a random, this y is a random variable. And we have a data set, so we're given a data set. Our data set is x1, y1, xn, yn. There's our data set. And our goal is to estimate beta 0 and beta 1. So we estimate beta 0 and beta 1 by minimizing this expression over here. I'm going to call this expression over here S, which is going to be a function of two variables, beta 0 and b0 and b1. Now b0 and b1 are going to be the estimates. So I want to minimize this. I want to minimize the sum. J goes from 1 to n of the actual data points I'm given, yj, the known data points to us, minus beta b0, in this case the estimating value, b0 plus b1 xj, quantity squared. So this is the sum of square of errors, right? This is the actual data point we know, and this is what we're going to try to estimate this by. We're going to have this actual line, b0 plus b1 xj, or b0 plus b1 x. We want to figure out which of those lines is best that will minimize this. So to minimize this, we'll do the derivative with respect to b0 and b1 instead equal to 0. In other words, we're going to compute the gradients of this with respect to b0 and b1 and set that gradient equal to 0. So the first term in the gradient is the 0 vector, of course, 0, 0. The first entry over here, if I do the derivative of this with respect to b0, that's going to be good. So we'll have what? We'll have the sum, j goes from 1 to n, of a negative 2, and then a yj minus b0 plus b1 xj. That's the first entry we're going to have over here. And the second entry over here is going to be what? It's going to be the sum, j goes from 1 to n, of, again, a negative 2. But now the xj is going to come out by the chain rule. So I'm going to have a negative 2 xj, and then yj minus b0 plus b1 xj. And this is set to be equal to 0, 0. So now what we have here is we have two equations, and we have two unknowns. We have an equation, for this first entry is an equation, the second entry is an equation. So let's look at this first equation over here. The first equation over here, the negative 2 is irrelevant actually. The first equation tells me that the sum, and I'm going to drop the j goes from 1 to n, the sum of yj minus b0 plus b1 xj has to be equal to 0. Let's actually write that in this case, j goes from 1 to n, okay? And so now notice over here, and this is an important observation, that if I sum all these yj's, if I sum either all the yj's, j goes from 1 to n of yj, or the sum, j goes from 1 to n of xj, what I get for either of these things is going to be n times the average of those things, because 1 over n times this sum is the average. So if I multiply both sides of the average by n, I get this relationship over here. So what this will tell me over here is this is going to tell me that n, and then I have the sum of the yj. The sum of the yj will be n times y bar. Then I'm going to have n b0s over here, because b0 is a constant. So I have b0 n times, so I have minus n b0. And then I have what? Now I have a summation over here. Now I have a minus b1, minus b1, and then I have the sum of xj. So that's going to be n times x bar. And this has to be equal to 0. So there's a common factor n everywhere, so we can cancel all those n's. And the conclusion here is that what? The conclusion here is that b0, if I throw the b0 to the other side of this equation, which is called a score equation, that b0 is equal to what? Is equal to y bar minus whatever b1 happens to be, b1 x bar. So as long as we're consistent, this is a relationship between b0 and b1. So now I have the intercept parameter in terms of the slope parameter. Now I'm going to use the second expression over here to find out what the intercept parameter is going to, what the slope parameter is going to be. Again, we can cancel out that 2. It's irrelevant. So let's go back to our equation. Our equation tells us what? Our equation tells us that the sum, j goes from 1 to n. Then I have an xj, yj. So I'll have an xj and then a yj. And then we'll have a what? Then we're going to have an xj times a b0 over here. So now we can cancel that negative 2. So we're going to have xj b0 with a negative sign. So that's going to be what? It's going to be negative b0. Pull that out. And then I have the sum of xj, which is going to be n times x bar. And then we're going to have what? Then we're going to have a negative b1 xj times xj. So that's going to be negative the sum. J goes from 1 to n of xj squared. So I have an xj, xj, and these terms are all multiplied by b1, and we set this equal to 0. So let's just double check. So the first term we have, the negative 2 cancels out. So we have xj, yj. We have that sum right over here. Then we have xj times b0. So that's going to be a negative b0 and then nx bar. That's that term. And then finally we have an xj, negative b1 xj. That's b1 xj squared. Excellent. So now, what can we do? So now, we can solve this for b1. So we'll put the b1 on the other side. So this says that b1 times the sum, j goes from 1 to n of xj squared, is equal to what? Is equal to the sum, j goes from 1 up to n of xj yj, minus b0 times n x bar times n times x bar. Good. So our relationship says that b1 is equal to the sum xj yj, j goes from 1 to n, minus n x bar times what? N x bar times b0. But what's b0? b0 is y bar minus b1 x bar all divided by, and let's keep the sum of xj squared over there. I can divide this whole thing by the sum of xj quantity squared. J goes from 1 to n. Okay? So now what do we have over here? So we can just keep it like this, and we can basically take this relationship over here and take what, so relate this over here as the sum xj yj, and then minus n x bar times y bar, and then minus b1 x bar. And I'll throw that b1 x bar on the other side of the equation with an n. So what we'll have over here is we're going to have a b1 times the sum, j goes from 1 to n of xj squared. And then this other term over here will be a what? This is going to be a positive n b1 x bar squared. So then I'll have a negative n x bar squared is equal to the sum, j goes from 1 to n of xj yj, and then minus what? And then a minus n x bar y bar. So the final relationship we have is that we get that b1, the slope estimate, is going to be the sum xj yj, j goes from 1 to n, minus n x bar y bar, all divided by what? All divided by the sum, j goes from 1 to n of xj squared, minus n x bar squared. So this relationship over here, so now I have found b1 just in terms of the xj and the yj, and the x bar and the y bar, which are functions of the xj and the yj. So this b1 is my slope estimate, and once I have b1, I can fill it into this equation and find b0, which is the intercept estimate. Thank you very much.